Yes, today we are at 5.2 trigonometric functions and real numbers. So we are actually going to define now some of the trig functions that we want to talk about. When you guys were in geometry, you defined SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We are not doing that today. I never thought of sine, cosine, and tangent as SOHCAHTOA until I was tutoring a student one year, and they told me, they said, well, I use SOHCAHTOA to figure it out. I said, I've never heard that before. I know it sounds silly, but I always thought of it in terms of just sine and cosine and tangent in terms of the unit circle. And I'll show you exactly what that means. Define the following trig functions. Sine of theta is going to be equal to y divided by r. So this is given that theta is an angle that has a terminal position of the angle at a certain point P that we refer to as xy. So those coordinates that we talked about the other day, if you glance at this sheet, you can see that these coordinates are what I'm referring to, okay? Negative square root of 3 over 2 and 1/2. That would be an example. So, for example, if I ask what is the sine of pi over 6 or what is the sine of 30, you would take the y value, which is 1/2, and divide it by the radius. What is the radius in a unit circle? 1. So 1/2 divided by 1 is 1/2 divided by 1 is 1/2. So really it's just the y value. So we can write this. It's equal to just y in the unit circle because the radius is 1. So if we're working in the unit circle and the radius is 1, then sine of the angle is simply just 1/2. Okay? All right. Cosine of theta is x. The x value of the coordinate divided by r, or just x, yada, 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 if we're working in the unit circle. Anybody want to take a guess at what tangent is? Y over x. Now, please make an important connection here. Y over x. Y is the rise, or the vertical displacement. X is the run, or the horizontal displacement. Yep, same thing as the slope. So if you were to take the tangent of an angle, that would give you the slope of that line. Kind of neat. Cosecant, secant, and cotangent are inverses of these functions. So inverse means that I flip it upside down in this scenario, okay? So sine of theta and cosecant of theta are related. If sine is y over r, then cosecant is r over y. And secant is r over x. And cotangent is x over y. R is the radius, and in the unit circle it is 1. Remember that the definition of the unit circle is x squared plus y squared equals 1, and the equation for a circle is x squared plus y squared is equal to r squared. So that's where I'm getting the r squared. Let's say we were working in a different circle where the radius wasn't 1, then I would be referring to that. What's that? CSC stands for cosecant. Secant is just secant, and then cotangent. So we have sine, and it's interesting. Sine originally refers to half of a chord. In ancient times, they would look at an angle, and they would eventually divide that angle in half, and this distance y represented a half chord. The first term for sine was a half chord. It got translated through Arabic and Latin, and it ended up as sinus. So the same thing as your nose. It was mistranslated a number of times. It came up to be your nose, basically. So that's not what sine actually means. It means a half of a chord. That's what it's supposed to mean. Question? Yes, go ahead. So here we are. We're at this spot right now. It says draw a picture and use special triangles to calculate the exact value of the following trigonometric functions. And when I say special triangles, I'm referring to 30, 60, 90 or 45, 45, 90. So this is the hardest stuff that we'll do today. The other stuff is a little bit easier. So I want to do the sine of pi over 3. And first of all, to try to construct an image in my mind of what pi over 3 is, what is that in degrees? Do you know? 60. So this is the same thing as sine of 60 degrees. So what I'm going to do is I'm going to draw a circle, and I'm going to draw a 60-degree angle. And in order to calculate the sine of 60, I need to find y and r. Well, if I'm working in the unit circle, what is r? R is 1. But I need to find this coordinate right here. If I could find an x value and a y value, I'd be in pretty good shape. So we have a 60-degree angle. Whoop. We have a 60-degree angle. And if I drop this down, okay, so this is 60 degrees here. And you already told me that the radius is 1. In a 30, 60, 90 triangle, how does the shortest side compare to the hypotenuse? Half. So the x value is 1/2. How do I come up with the vertical part? Multiply it by the square root of 3. So you take 1/2 times square root of 3, you get square root of 3 over 2. So my y value is the square root of 3 over 2, and my r value is 1. In order to calculate the sine of pi over 3, I take from what we've defined up here. I use this formula, y divided by r. If you take y and divide it by r, what do you get? Square root of 3 over 2. So the sine of pi over 3 is equal to the square root of 3 over 2. And if we set our calculator to radians and we typed in sine of pi over 3 on our calculator, you would come up with the square root of 3 over 2, which is approximately 0.866. Okay, so we're just defining this. We're not using it yet. Trigonometry and statistics are two of the most applicable studies in mathematics that we have. Okay, and we're working with trigonometry right now. And we will apply it all over the place. We'll get great word problems, we'll get great graphs, all sorts of stuff. Right now we're just defining these in terms that we can understand. If you forget those definitions, I've put them on your graphic organizer. As you can see right down here, it says definition of the 6 trigonometric functions. All of those are listed for you. Hopefully that'll be helpful. Is that helpful? All right, great, thank you. So, all right, let's do the cosine of -5 pi over 3. Well, first I need to know where that terminal spot of the angle ends. So I'm going to have to figure that out. What is -5 pi over 3 in terms of degrees? How many degrees would I rotate? -300. Very good. You guys are super smart. So I'm going to go -300. And if I do that, I will arrive at 60 degrees again. Hey, I've already calculated that before, haven't I? Do we know that coordinate up there? What is that coordinate? 1/2 and the square root of 3 over 2. Very good. And so in order to find cosine, I need to know x and r. Well, the radius is 1, and the x value is 1/2. So the cosine of -5 pi over 3 is equal to 1/2. So notice that the trigonometric functions say we don't have to take the sine or the cosine of positive numbers. We can also use negative numbers. And we don't have to restrict the domain from, say, 0 to 360 degrees. We can use all sorts of different numbers. And again, we don't know what this means necessarily yet, but we're defining the trig functions in this way, which is something you will do for the remainder of this course. So these basic pieces are things that we'll continue to work with. See if you can do tangent of 7 pi over 4 on your own. Go ahead. Yes, you are absolutely right. I get pop-ups all the time. I'm going to start to draw it up here in case you're concerned. Just some of my work that I would show. First, if you want to convert 7 pi over 4 to degrees, you multiply it by 180 over pi, and you get 315 degrees. That leaves me with this type of shape right here, which has a 45-degree angle. In the unit circle, you know that the radius is 1. How do you get x and y? You go 1 divided by the square root of 2, which we said is the square root of 2 over 2 the other day. I am in the fourth quadrant. I know that this side is the same. If I'm in the fourth quadrant, you tell me, is the x value positive or negative? Positive, square root of 2 over 2. Is the y value positive or negative? So negative square root of 2 over 2. In order to find tangent of theta is equal to y value divided by x value. What do you notice about your y values and your x values? They're the same except they differ by a value of negative 1. So therefore, if you divide it, you get negative 1. That is your correct answer. So I figured that most people have gotten part of this here. So Whitney, which part would you like to do over again? I think that this is the part, Whitney, that you want to see. Okay, which part would you like to see? Okay, so we have the square root of 2 over 2. You see that, right? Now, do you understand how I come up with that coordinate? My x value is here. My y value is negative because I'm going down. I'm in the fourth quadrant. So, in order to figure out tangent theta, I have to take the y value, divide it by the x value. If you take negative square root of 2 over 2 and divide it by square root of 2 over 2, or multiply it by the reciprocal, okay, flip over to the other side. Terminal point is defined by t. Find sine of t, cosine of t, and tangent of t. Okay, I have these points. I have an x value. I have a y value. I also need an r value in order to determine sine, cosine, and tangent. Now, Alex says the r value is 1. How could I confirm that the r value is 1? Yeah, if I plugged it in, negative 5 over 13 quantity squared plus 12 over 13 quantity squared. If I got 1, then, I'm working in the unit circle. And negative 5 over 13 squared is 25 over 169. 12 over 13 squared is 144 over 169. 169 over 169, which is 1. So I'm working in the unit circle. So my radius value is 1. So if I am at this point, negative 5 over 13, and again, what this is saying is that if you look at this coordinate, negative 5 thirteenths and 12 thirteenths, so that might be somewhere right around here, okay? Negative 5 over 13 and 12 thirteenths. You're looking for the sine of that angle or the sine of that distance, okay? That's what we're working with right here, okay? And by definition, the sine of t is equal to what? y over r. And so that's going to give you what value? If you take y and divide it by r here, you get 12 over 13. This point is not real crucial as long as I end up in the second quadrant. If my x value is negative and my y value is positive, that makes me in the second quadrant. But whether I place that a little bit further to the left or the right doesn't matter at all. Doesn't matter. No, I did not. I put a point on the circle. That's all I did. I could have put it over here, and it wouldn't have made a difference. T is, we talked about on Friday, that T is technically the length of the arc, but we said that in the unit circle, the length of the arc is the same thing as the angle measure. So T and theta are technically the same. They're really the same. Your book uses T to represent the arc measurement there. Theta is the angle measure. They are the same. Cosine of T would be what? Negative 5 over 13. And tangent of T, how would I figure that out? Yeah, I would take 12 over 13. And I would divide that. Divide that by negative 5 over 13. And instead of dividing, I should multiply by the reciprocal. And the 13s cancel, and I get 12 over negative 5, or negative 12 fifths. So that would be the value of tangent. See if you can do B on your own. Try B on your own. You don't have to graph it. I drew the visual for you so that you could understand that this was a point sitting in the second quadrant and that T represented the arc length as well as the angle measure. They happen to be the same. Okay, for this problem, here's what you should have. The sine of T is going to be equal to the negative square root of 5 over 3. We are working in the unit circle. If you squared both values out, you'd find that r is equal to 1. Cosine of T is also equal to just negative 2 over 3. If both values are negative, which quadrant am I working in? Working in the third quadrant. And tangent of T is equal to, I would take the y value divided by the x value, and if you notice, the denominators cancel, and you'd be left with a positive square root of 5 over 2, should be your value for tangent. Now, if you flip to your graphic organizer I gave you, there's something really important that I want to talk to you about, and that is where sine, cosine, and tangent are positive. There's not a way that you're supposed to necessarily remember this. You need to come up with your own method. I provided a couple for you. I just remembered it. I just decided I'm going to remember it, and so I did. I remembered where x was positive and y was positive and stuff like that. You do it however you want, but here's one method. If you look at this right here, it says positive quadrants, okay? On the bottom here, positive quadrants. Sine, cosine, and tangent have to do with x values, y values, and r values. True or false? A radius of a circle can sometimes be negative. False. A radius is a length. Always positive. So therefore, whether or not one of these functions is positive really rests on x and y. So in the first quadrant, what is positive? X, y, or both? Both. So therefore, sine, cosine, and tangent are all positive in the first quadrant. When you move to the second quadrant, what becomes negative, x or y? X becomes negative. Which two trigonometric functions, sine, cosine, or tangent, have to do with x? Cosine and tangent. Sine doesn't. Therefore, sine remains positive. Cosine and tangent are negative. If you go down to the third quadrant, what's negative, the x value or the y value? Both. So sine will be negative, cosine will be negative, but tangent is x or y divided by x. So if you divide two negatives, you get a. So therefore, tangent is positive. And if you're over in the fourth quadrant, what value is negative, x or y? Y. And tangent and sine have to do with y. Therefore, those are negative, and cosine remains positive. So here's how some people remember it, and it doesn't apply to very many of you in this class, but this is the way that it's often talked about. I don't care what you say or what you do. You can remember however you want, but all of them are positive in the first quadrant, correct? So then sine, some people instead of saying sine, they say seniors. Remember sine begins with an S, so all seniors. And then T for tangent, they use the word take. All seniors take calculus, which is entirely not true. But you will even see that in books from time to time. That's a saying that everybody came up with. I think it's to try to encourage you that are juniors that you should take calculus next year. Okay, so all seniors take calc. Okay, there you go. So I don't know if that helps you remember it, but that's what some people say. No, I never heard of it before I started teaching somewhere. I don't know if it was here or where, but I didn't remember it like that. I remembered it the way I explained it to you guys. I thought of where x and y were positive and where they were negative, and that's how I remember it. So I never go through that. So it says as follows. Find the values of the 6 trigonometric functions given the following information. So let's list all 6. Sine of t, cosine of t, tangent of t, cosecant of t, secant of t, cotangent of t. 6 trigonometric functions. Now, because I have all 6 of them, I need to know x, y, and r. It says that sine of t is equal to negative 4 over 5. And it says that t is in the third quadrant. Okay? Now, before I do any other work, I just want to define something here. If I know that sine of t is negative 4 over 5, there's another trig function up here that I can figure out very, very, very quickly. Anybody know what it is? The one right across from cosecant is going to be what? Negative 5 over 4. There you go. Now, sine is equal to which value? My x, my y, or my r? My y value. Okay, so my y value is going to be negative 4 over 5. Furthermore, it says I'm working in the third quadrant. If I'm working in the third quadrant, tell me, we know sine is negative. Is cosine positive or negative in the third quadrant? Cosine is negative in the third quadrant. So you know you're going to have a negative sign for cosine and a negative sign for secant. What's that? You're going to have to refer to the chart and realize that tangent's the only one that's positive in the third. And so we know here that tangent is positive in the third by what we just said. So I have y. What is r? R is 1 in the unit circle. So how could I figure out x? Very good. X squared plus y squared. What is negative 4/5 squared? 16 over 25 is equal to your radius squared, which is 1. Subtract 16 over 25 for both sides. X squared equals 25 over 25 minus 16 over 25. And you get x squared is 9 over 25. Square root both sides. X is 3/5. Now, positive or negative, we already decided. We already decided if it's positive or negative. It's going to be negative here, so negative 3/5, negative 3/5, or 5/3, excuse me. How do I figure out tangent? Y over x, so I take negative 4/5 and divide it by negative 3/5, and you get positive 4/3. Cotangent will be the reciprocal of that, which is 3/4. Questions? We try one more. Here I'm given that the cosecant of t is equal to -2, so I can list that right now. If I know cosecant of t is -2, what other value do I know right away? What is the sine of t then? -1/2. So I have those two values listed. I need to figure out x, y, and r. X, y, and r. I already know that y is -1/2. I know r is 1. First, let's decide whether my values are going to be positive or negative. It says that the cosecant value is negative, and it says that cotangent is less than 0. What does it mean to be less than 0? It's negative. So if cosecant is negative, so is sine. And if tangent is negative, or if cotangent is negative, so is tangent. Where are both sine and tangent negative? Fourth quadrant. We've established we are in quadrant 4. So I know that tangent is going to be negative. I know that cotangent is going to be negative. And I know that cosine is positive in the fourth, as well as secant. So I know my signs, positive or negative. And yes, those signs will give you points on the test. Every year when I grade trig tests, a lot of times people come up with the right numbers, but they don't put the right sign. That matters a lot in these situations. How do I come up with x? X squared plus y squared. What's -1/2 squared? 1/4 equals r squared, which is 1. Subtract the 1, or 1/4, excuse me. X squared is equal to 3/4. Square root both sides. I square root the numerator, and I square root the denominator. What is the square root of 3? Square root of 3. And what's the square root of 4? 2. And again, we have positive or negative values. We've already decided which they would be. Cosine is equal to positive square root of 3/2. How would I get secant? 2 over the square root of 3. Can't do that, can you? So I multiply the top by the square root of 3, bottom by the square root of 3, and I get 2 square roots of 3/3. Good. And tangent, what do I need to do there? So that means I would take -1/2 and divide it by square root of 3/2, or multiply by the 2 over square root of 3. 2's go away. -1 over the square root of 3. Can't have the square root of 3 in the denominator. Negative square root of 3/3. Everybody watch this one last piece. It'll save you a few seconds here or there. I came up with -1 over the square root of 3, right? And we can't have the square root in the denominator, can you? But if I flip it and make the reciprocal of it, that would give me cotangent, right? Which is what? Square root of 3. That way I don't flip 3 over the square root of 3 and end up with the same problem. So there you have it. I'm undecided about tomorrow. I have to look at where we're going. We might play a game tomorrow. Okay? We might play a game. We'll see. But you will not have 45 minutes of instruction tomorrow, I can tell you that right now. Please make sure you start working on this. It's so important in the beginning of this stuff. Trust me, it'll get easier in the next couple weeks. Here's your assignment. 3 through 7, odd. 15 through 19, odd. 27 through 29, 61, 62, 65, 66. It follows exactly what you see in your notes. Might have to skip watching The Bachelor tonight and do some pre-calculus homework.